everyone, welcome to a new video on AI World for You. In this video, let us see one of the uninformed search strategies, which is DFS, Depth First Search, and let us see its properties and advantages, disadvantages, applications, and let us discuss one example to understand DFS better. So, uninformed search itself means that the search algorithm is going to perform the search without prior information or domain knowledge about the goal state. Under uninformed search categories, we have different search algorithms. In the previous video, I have shared about BFS, which is breadth first search, and I have shared the link in the description. Now I will discuss about DFS. What is DFS? Depth first search. As the name suggests, the search algorithm is going to execute the search with depth, not with breadth. That is, it is going to go deeper into the node and explore the goal. So starting from the root node, it will go deeper until the greatest depth node and then move to the next path. So DFS will use stack data structure and it will go on exploring until it reaches the goal node. In case of DFS, even backtracking is possible. That is, if the node from one level and if it reaches the successor node, again it can go back to the parent node and go to the exploring other neighbors. Therefore, backtracking is also a very important feature of DFS. Let us consider this graph given here. We have S and it has two successors A and H, and A has two successors B and C. H has two successors I and J. This B has two successors D and E, and C has one successor which is G, and that is our goal node, and I has one successor which is K. So, in order to find and reach the goal node, how DFS will execute the search? First, it will start from the source node or the root node. Initial state is S. So, it will start with S. Then, it will go to explore who are the successors of S. The successors of S are A and H. So, it will consider any one only. So, it will consider A first and pick A. Then, it will go deeper into the exploration and dive deeper into A. So, A has two more successors B and C. Therefore, first it will go and check B. Now it will go deeper into B and explore B. So, from B it will go to D. And now it has not reached the goal node yet. So, it needs to backtrack and go back to the B, and then search for the next successor of B. So, from S it goes to A. Let me put it down. From S it goes to A and then to B and then to D. This is like exploring deeply of one specific node. It is not going for searching all the nodes of a level. It is going deeper. That is why we are calling this as depth first search. And here, once it has gone up to the depth D, there is no further successor to explore and the goal state is also not reached. So, it needs to backtrack and go back to B. So, again it will go back to B, but we won't mention that here because B is already visited. B is an already visited node. So, no need to mention B again. From B, now it will go to E. So, we need to mention E, and then E is also not the goal node. So, again it will go on exploring. It will backtrack and go to B. Again it will backtrack and go to A. And since they are all visited, we need not mention that here. Now from A, it will take the other route which is an unexplored path, which is C. So now it will go and explore C and then the successor of C, which is G. Since the goal node is reached, the DFS implementation stops right here. So this particular algorithm will go on exploring a node until the last depth, until the shallowest depth we will say. And in case the goal node is not reached, it will backtrack and go to the previous node and check if it is any unvisited node. If it is an unvisited node, then it will visit that. And if it has any unvisited successors, it will visit that. Then if it has no unvisited successors, it will backtrack and go to previous level and check whether any other successor node is not visited. Then it will check the unvisited successor node and go on until it reaches the goal node. So the path over here for DFS implementation is S to A to B, B to D, D to E to C and C to G. Since G is the goal node, the implementation stops right here. So if you observe, there are some unvisited nodes here. The algorithm has not visited H or I or J or K. So that is the major difference between BFS and DFS. In DFS, the goal node will be reached faster, or it may not be reached in case it is looking in the wrong place. But BFS will explore all the nodes, whereas DFS will just go on exploring the depth, that is, it will go on exploring a specific node until the goal node is reached. Here the shortest path will be S, A, C and G, right? So here I have given the shortest path, and the actual DFS implementation is S, A, B, D, E, C, G. Coming to the properties of DFS, we have to check the 4 major properties for any algorithm, that is completeness, optimality, time complexity and space complexity. Coming to the completeness, DFS algorithm, we will say that it is complete within the finite state, but it may get stuck in infinite paths sometimes. And coming to the optimality, we say that DFS is non-optimal as it may generate a large number of steps or high cost to reach to the goal node. Coming to the time complexity, we say that it will be equivalent to the node traversed by the algorithm. So in case it is going in the right path and finding the goal node, then fine. But in case it is getting stuck in an infinite loop, then it will go for occupying or taking more time to complete the task. And space complexity, we will say that it is very much space efficient, because in DFS not all the nodes are visited. So whichever nodes are visited, only they will be stored in the memory location. Therefore it will occupy very less space. Therefore we can say it is highly space efficient. Coming to the advantages and disadvantages of DFS, it requires less memory. That is one of the major advantages of DFS, and it can be implemented easily with recursion, and it may find a solution faster than BFS in some cases. In the example which we considered right here, it has found the solution even without going to the other side and exploring the other nodes, right? And it is useful for tasks like topological sorting, cycle detection and path finding in large graphs. Coming to the disadvantages of DFS, it may get stuck in infinite loops. That is one of the major drawbacks, and also it does not guarantee the shortest path, and it may explore long and go and explore unhelpful paths as well. Coming to the applications of DFS, it is useful in solving puzzles like Sudoku and graph traversal in compilers and interpreters, artificial intelligence in exploring game trees, backtracking problems such as n-queens problem, and topological sorting and cycle checking. So in this video, we have seen about DFS and its advantages, disadvantages and implementation with an example. I hope you understood how to go about with depth first search. And if you like this video, please hit the like button and subscribe to our channel for regular updates on AI and AI related content. Thank you for watching.